The generic term unit refers to how much of an effect a drug formulation has on a particular biological readout. The anticoagulant heparin is an example. 1 unit of heparin was originally defined as the amount of heparin extract needed to keep 1 milliliter of cat's blood from clotting for 24 hours at 0 degrees Celsius. Units are used in preference to other more specific measures like milligrams in situations such as when the active compound in an extract has not yet been identified, or when a partially purified extract is being used because the active ingredient is difficult to purify. This was the case with heparin when it was originally being isolated from liver extracts. Now that pure heparin can be more easily obtained, it's no longer standardized to cat blood, but it is still measured in units. Now, a unit of heparin activity has a potency equal to 0.002 milligrams of pure heparin. Units can also be used when there are several related compounds that exert the same biological effect. In this case, units provide a uniform way of comparing the biological activities of the different compounds. For example, units are still used for vitamin A, which has a retinol form and a beta-carotene form. Like heparin, insulin is another example of a drug that was initially difficult to completely purify and that is still measured in units today. However, it is important to remember that because each drug has a different biological effect, the meaning of the term unit differs from drug to drug, and each will have its own conversion factors. For calculations, you'll be expected to memorize and use the meanings of the insulin unit abbreviations on the slide. So, U500 insulin refers to 500 units of insulin per mil, U100 insulin, 100 units per mil, and U50 insulin, 50 units per mil. A common problem type with insulin is calculation of correction factors. Insulin correction factors are used when blood glucose is outside of a specified range. For example, if a patient with a blood glucose reading of 190 milligrams per cent has been asked to take 1 unit of insulin for every 30 milligrams per deciliter over 150 milligrams per deciliter of blood glucose, the correction would be as follows. We have a target blood glucose of 150 milligrams per deciliter. The patient's blood glucose was measured at 190 milligrams per cent, and we hopefully remember that milligrams per cent is the same as milligrams per deciliter. So the amount of excess blood glucose is the measured minus the target, 190 minus 50, which equals 40 milligrams per deciliter. Well, the patient was asked to take 1 unit of insulin for every 30 milligrams per deciliter over the target. This patient has 40 milligrams per deciliter excess blood glucose. So the question is, how many units should the patient take? And if we crisscross with this proportion, we'll see that the patient should take 1.3 units of insulin. Let's look at a few more examples. In the first, a patient has an insulin correction of 1 unit for every 20 milligrams per cent over 180 milligrams per cent. The patient's blood glucose was 275 milligrams per cent in the morning. So how many units of insulin should be administered for the correction? Well, first of all, we can look at and see how much over the target the patient was with their morning blood glucose reading. It was at 275 milligrams per cent. The target was 180, and so the excess blood glucose was 95 milligrams per cent. Patient's supposed to take 1 unit for every 20 milligrams per cent over, and so the proportion looks like this. And after cross-multiplying, we see that the patient should take 4.75 units of insulin in this situation. The next question is a weight-based type of dosing. It gives an order of 2.5 units per kilogram of patient weight. They're supposed to take Humulin N U100 insulin, and the patient weighs 145.5 pounds. The question is, how many mils of U100 insulin should be administered? Well, first of all, we see the weight-based dosing is in kilograms and the patient weight is in pounds. And so we can set up a proportion like this, in which we know from our conversion factors table that there's 2.2 pounds per kilogram. The patient weighs 145.5 pounds. And so the X number of kilograms is 66.14. Next, the weight-based dosing says that 2.5 units should be given for every kilogram of patient weight. This patient weighs 66.14 kilograms. So setting up a proportion like this, and I think this should be an equal sign right here, tells us that the number of units the patient should take after crissing is 165.34. And finally, the concentration of insulin is given right here. It's one of the abbreviations of insulin concentration we needed to memorize. It tells us there are 100 units of insulin per mil of the injection solution. If the patient needs to take 165.34 units, how many mils is that? And the answer we get is 1.65 mils. The final example is another weight-based dosing question, but this time involving heparin. The patient's supposed to take 120 units per kilogram of heparin, and the patient weighs 220 pounds. So how many mils of a 5,000 unit per mil heparin injection should be administered? Well, once again, we've got this discrepancy between kilograms and pounds. There's 2.2 pounds per kilogram. Patient weighs 220 pounds. So number of kilograms is 100. Next proportion we can set up is the weight-based dose. So there's 120 units that should be given per kilogram of body weight, and the patient weighs 100 kilograms, and so the number of units they should be taking is 12,000 units. Finally, the heparin injection concentration is 5,000 units per milliliter. The patient needs 12,000 units, and so the number of milliliters is 12,000 divided by 5,000. That's 2.4 milliliters of the heparin injection.